Hello! So today we are gonna learn about hopper design. Oh, before that, have you ever wondering how coarse flour can be stored? Any powdered materials can be stored in a hopper. So what is hopper? A hopper is a straight wall vessel of circular or square cross-section with a tapered conical or tapered square section base. It is filled at the top and must be vented for both filling and emptying. Hoppers are used in industry for protection and storage of powdered materials. Type of hopper flow: mass flow and funnel flow are the flow regimes for powders discharging from a storage silo. A hopper design will affect, first, rate of flow of the powder out of the hopper if it flows at all. Second, how much of the stored materials and whether there is mixing of solid sizes or dead space that reduces the effective holding capacity of the hopper. Hopper design calculation for coarse flour. Step 1. Read a journal and get all the important data such as bulk density of coarse flour, diameter of coarse flour, effective angle of internal friction, and kinematic wall of friction. Step 2. Based on effective angle of internal friction, which is 30 degree, and kinematic angle wall of friction, which is 26 degree, we can get the semi-included angle, which is 13 degree, after minus with 3 of safety margin. Hence, we can read the hopper flow function FF from the graph, which is 1.65. Step 3. Plot a graph of powder flow function based on the values of sigma y and sigma c from the journal. So this is the graph that has been plotted. Step 4. A limiting condition flow needs to be plotted in order to obtain sigma critical. The intersection between powder flow function and limiting condition flow gives the sigma critical, which is 2.4 kN per meter square. Now let's proceed to step 5. The conical outlet H theta of the hopper need to be calculated using the formula stated. The theta is referred to the semi-included angle, which is 13 that we calculated in the step 2. Hence, the H theta obtained is 2.22. Step 6. Once we know the conical outlet of the hopper, the sigma critical, and the bulk density of coarse flour, now we can calculate the minimum hopper outlet diameter, which is B, using the formula stated. Hence, the diameter obtained is 0.84 meter. Step 7. Height of hopper need to be determined. Note that the diameter of silo, denoted as ds, we estimate to be 1.3 meter, which is bigger than the diameter of hopper dh. After inserting all the values in the formula, the height obtained is 0.996 meter. Step 8. Now, we have to determine the height of silo by using heuristic of h over d equals to 3. The diameter of silo is 1.3 meter as we assumed in previous calculation, hence the height of silo is 3.9 meter. Step 9. Now we have to calculate the volume of hopper, volume of silo, and total volume for both by summing up the volumes obtained. For the volume of hopper, we use the equation of frustum of a cone for a circular hopper. The equation is V equals to 0.262 h times ds square plus dh square plus ds times dh, and the volume obtained is 0.91 meter cubed. For the volume of silo, the equation of cylinder is used. The volume calculated from the equation V equals to 0.785 d square h, where d equals to 1.3 meter and h equals to 3.9 meter, hence the volume is 5.17 meter cubed. For the total volume for both silo and hopper, we sum up the volume of silo and the volume of hopper, and the total volume obtained is 6.08 meter cubed.
Pneumatic transport. What is pneumatic transport? First, every pneumatic transport or system makes use of pipes or ducts called transportation lines that carry mixture of materials in a stream of air. Second, pneumatic transport is routinely used to move solids, usually small particles of all sizes, within process plants. Third, energy is also required to move material or particles through a pneumatic conveying system, but in the case of energy is supplied by pressure differential. Fourth, in a pneumatic conveying system, the air pressure in the conveying line is changed by the system's air mover, which generates one or the other. Finally, the air mover pulls air through the system and the system runs under vacuum. By controlling the pressure and airflow inside the system can successfully transfer material. This is the schematic view of the flow of the coarse flour, starting from the silo, flowing into the pipeline, and ending in the fluidized bed dryer or receiving bin. In order to calculate the pressure drop along the pipeline, there are 3 steps must be followed. First, the selection of pipe size. The pipe diameter is set close to minimum outlet dimension of hopper, end. By referring the American Standard pipe dimension and weight, the size of pipe would be selected. Second, determine gas velocity. By using the risk correlation as shown, the superficial gas velocity can be determined, where the U node is equal to the 1.5 U salt. Third, the pressure loss calculation. The R3 main parts shall be calculated in order to perform the pressure loss calculations. Horizontal sections. Vertical sections. The graph that need to be used to identify the terminal velocity. And bent sections. Each parts have their specific formula that should be used. Therefore, the total pressure loss along the pipeline can be calculated.
What is fluidization? Fluidization is a process similar to liquefaction, whereby a granular material is converted from a static solid-like state to a dynamic fluid-like state. This process occurs when a fluid, liquid, or gas is passed up through the granular material. This is a basic design of fluidized bed dryer. Fluid is passed through the solid particles and mixes together whilst drying the particles. Air is commonly used as the fluid in the dryer. Based on the diagram, we can see the effects of increased velocity to the pressure drop within the bed. You can see that at point A, the pressure drop starts to become constant. This point is known as a minimum fluidization velocity. From the diagram, we can conclude that in order for fluidization to occur, the gas velocity has to be greater than a minimum fluidization velocity. To calculate the minimum fluidization velocity, there is 2 ways to calculate this. When U correlation and Bayes-Engel-Dart correlation. The calculation is based on the size of the particles within the bed. If the particle is bigger than 100 micrometer, when U is used. But, if it is less than 100 micrometer, Bayes-Engel-Dart is used. Finally, this is how the process of fluidization that can be observed in the dryer. Please leave a like on our video. Thank you.